Okay, so hello everyone. I hope I'm audible and you are able to see my screen. I've been hearing a lot about the awesome sessions that have been going on. So by now you should be familiar with the with Kubernetes, Containerd, what Civo platform is, how to deploy the application, differences between K3s, Kubernetes. What is the Civo platform offering, which is Civo Kubernetes, how to deploy the application on Kubernetes. So I think that that gives you the essence of what all things you can do with Kubernetes, how you can deploy to Kubernetes, how you can use a Civo platform for creating the clusters, installing the marketplace applications and whatnot. In this particular session, I will be going over the Kubernetes observability piece, and we'll have a lot of fun with this. So let's get started. Let me just do my screen presenter mode. I see a couple of folks already joined, so hello, hello, hello. And just keep sharing that because this will be a really interesting session. I have prepared a couple of demos. We'll do live demos. Yes, I feel like doing live demos, and when the things break, it is more fun because we get to fix them live. Interesting. Let's get started, and I will present my screen. Cool. So a bit about myself. I'm working with Civo as director of technical evangelism. A lot of stuff I'm doing. You can see me active in the community, and all that stuff. You can find me on Twitter at the Saiyam. I'm very active over there, tweeting about the new tech and the work that I am doing within outside of the community. Then I'm a CNCF ambassador, and all the things that you can see. Important thing to note is I run my own YouTube channel where you'll get the best out of cloud native. So all the latest and the greatest projects, different types of weeks like CI/CD week, Knative week. They all will be there, so you can check that. And It's sayampathak.com/YouTube. You can subscribe to that, obviously, if you want to get the notification. I have a stream today as well at 9:30 p.m. IST or 8 a.m. PT, whichever time zone you are joining in from. I am also the author of Let's Learn CKS Scenario book, which is based on Kubernetes CKS certification. So I think that's more than enough. So we are starting with observability. I will tell you, we are observing the Kubernetes clusters. We want to observe. We want to see what is happening within the applications of the Kubernetes cluster, within the and what all things are there actually. Because we have to start from the scratch, right? So the observability pillars. So observability stand on some pillars, and actually there were three very recently, not very recently, but there's a fourth pillar which have been added and which is now a distinct part of the observability, which is profiling. So the observability layer or the pillars remain kind of same. So it's basically observing anything. These four pillars will remain the same. So first you have the metrics. So anything related to like how much memory, or what is the application requests that is getting the statistics, and the data which will be aggregated in terms of which can be counted. They are sort of the metrics. And then you have tools on top of that which can which can scrape that metrics. So you will be having certain statistics, certain stats, certain metrics, which is kind of time series metrics. So you'll be having those in terms of like you know CPU memory, or in terms of Kubernetes, because now you're familiar with that. Like what is the pod pod CPU usage, and the pod CPU mem usage. So all those metrics will be there. It tells you like how the it tells you about the system performance, the applications, how they are doing. And each and every metrics have a lot of details, which when scraped, I will tell you like how we can scrape the metrics. So when you scrape that metrics, you can analyze that, put that in fancy graphs, and then set alerts on top of that. So if any metrics here goes here and there, and you should be getting alert for that. So that's how it works internally. Then you have I would say you can pick any. So then you have logging. So if you are familiar with the application development, then you must have heard of logging, because you put the log statements in your application that gives you the plain text, debugging the application. It helps you actually uh, find the root cause of the problem. And when you talk about Kubernetes, so in Kubernetes it's a very huge system. So you must have heard in the morning, whether it's K3s or whether it's the Kubernetes K8s itself, there are different components, like the API server is there, the controller manager is there, you have your kubelet and whatnot, container D. So there are different components which makes the Kubernetes ecosystem. So even those have a lot of logs that that has to be analyzed if something goes wrong, because actually something will go wrong, we just don't know when. So for that, we definitely need to observe things in a very structured way. So structured logging is something which is very important. Logging can be very tedious and it can emit n number of logs, because when you have huge systems, when you have huge number of systems, when you have thousands of nodes connected to a Kubernetes cluster, then logging can be a mess. So make sure we are we are capturing the right set of metrics. So that is very important, right? We are logging we are logging the right set of data. That is very important as well. So now it's tracing. So tracing is kind of very important. Tracing gives, so let's say you have bunch of microservices, and suddenly what happens is a microservice, one of the microservices is slow. But now in a microservices architecture, you have a bunch of microservices and you actually don't know which one is creating a problem, where the exact issue is. Now we can actually trace each request that is going to a microservice. So if a request goes from A to B, B to C, C to D, D to F, or you can take any A to Z alphabets, now the request can be traced. And with this tracing, what we can find is where the actual issue lies. Now this becomes very important when we are capturing when we are seeing like what is happening inside the chain. So there is a complete chain and there's a bug which is happening only in one microservice, or there is a latency which is happening only in one microservices. Tracing will help us identify that. And there are tools like Jaeger, that are very much there in the CNCF ecosystem, that helps you in enabling the tracing. For logging also, you have the Elastic and Loki. For metrics, there are tons of tools. We'll talk about the tools as well. Then is the newest kind of which is not talked much, which is the profiling, kind of the performance, the performance stuff which is there. So not only we need to know, analyze the metric tracing logging, but we also need to see how the application is performing with respect to time. So we need continuous profiling of the deployments pods which are there in the Kubernetes cluster, so that we know the CPU benchmarks. We can know like over a time period. So let's say you have application A and there's a continuous profiling happening on that. Then you deploy a second version of that application, and it is going good. Now, how will you compare the performance benchmark for both the applications? So there can be CPU and memory consumption that your application was doing, but when you added the feature B to the application, then your application is not performing the right way. So now when you profile and when you tend to compare both the CPU and the memory, so you can find the difference. So profiling helps you identify the difference, so that now the newer version of my application is actually taking more memory and CPU. It is difficult, right? Let me just plug in the charger. Yeah, so it's very important, right? So that's why it is in the observability pillars. So that's where the observability pillars lies. And again, we can relate the Kubernetes monitoring to a lot of things. Now, why Kubernetes monitoring is actually important? How many times your Kubernetes cluster went down, or how many times your node went down. If you do not have monitoring enabled on your system and you are not tracking that, then you won't know over the period of 1 year what happened with your system, what happened with your cluster, how much stable it was, how much reliable it is. The reliability of platforms is very important. You can track the reliability if obviously if the downtimes are less and the number of failures are less, then your platform is reliable. Failure prediction, you can actually implement ML AI. There are actually tools which like Opni right now which do AI ops on top of the Prometheus metrics, which can predict the failure before even happening. So it will, based on the metrics and the CPU load generation and all that stuff, bunch of fancy things, it will let you know, it will predict the kind of failures. That is very important. And then you have the performance, obviously how your Kubernetes cluster is performing over the period of time. That is also very important. Current state. And now the thing is, when you install Kubernetes, there's the Kubernetes maintains its state. You must have heard from the previous sessions, like like I need a deployment with the two replicas, then it's the responsibility of the deployment controller to make sure that the two replicas, or the replication controller, the two replicas are always running. Now the thing is how it is getting to know. So internally, Kubernetes has its own set of metrics, which is in the Prometheus format that you can that you can uh, access. But this metrics is not stored for a long period of time. It is only to maintain the current state of the Kubernetes cluster. So that's how it is. Then the services visibility, how your services are doing over the period of time. Basically the applications, how they are performing over the period of time. So basically it's anywhere the observability is important. I think we all agree. And when you talk about a complex system like Kubernetes, the monitoring and the observability becomes very much important because of the components that it has. So there are tons of components which are already there in the Kubernetes ecosystem. On top of that, you deploy your applications. Now I think Kai would have explained you, like the difference between K3s and K8s, and that is where K3s is so lightweight and still gives you all the power, and that's why Civo Kubernetes is powered by K3s. It's lightweight, it's quick to start, good for developers. You can easily deploy your application and get it battle tested. There is no way you should not use K3s. You should definitely use. And all the entry cloud providers and bunch of other things which have been removed. So that gives you more lightweight stuff because it doesn't have those heavy building blocks which are separate components. So everything is as a single process which is running. uh, then what do we have next is monitoring is complex. Definitely there is lots of metrics. I told you, like there are lot of metrics, like many number of nodes. Don't think you'll always be running a 3 node cluster. You will eventually grow. You will eventually be 100 nodes and 200 nodes clusters, and you will be having multiple clusters. And then there will be challenges. You want to have you will be having multiple clusters, but you want to have a single view of the monitoring. I'll tell you how we can do that. So you have many pods, we have control plane components, we have node components, we have your application metrics. So I think many things are there. When you have short-lived containers, so you have ephemeral containers, too many objects are there and pods are moving all the time. So even if like Kubernetes, if one node goes down, then the responsibility of the Kubernetes to make it spin up on the other node. So things keep on happening like that. So short-lived containers, there can be a container which lived only for 10 seconds, but we have to capture that, right? So that is also very difficult. So that's where monitoring becomes complex. So that's why we need continuous monitoring, continuous profiling. So we that leads to like high cardinality, because the data is unique. The container names would be unique, and all that stuff will be there. So there will be high cardinality, and when there is high cardinality, then it becomes difficult for the time series databases, which is TSDBs, to query the data for longer duration. Your systems can hang up, or it can consume too much of CPU and memory. So that is where the cardinality has to be taken care very importantly. There are systems being developed in high performance languages like Rust. Even now the innovation is going on, like because Kubernetes is meant to have that high cardinality. We need to have the TSDBs that can handle the high cardinality. Then troubleshooting, obviously things fail, but at which level? So you need to troubleshoot those problems, and for that, obviously, if you don't have any monitoring, you won't be able to go back and see what happened and how to fix those, so that next time it doesn't happen. Then you have microservices architecture, and many services are there. Obviously you have to monitor all the services. So that is how that is why monitoring is complex. We need the monitoring solutions. And let's see, what are those monitoring solutions? So actually there are many monitoring solutions depending on the use case, depending on how complex is your ecosystem, how complex is your application, how much data retention you need, how much highly available or scale you need, and depending on multiple stuffs, there can be different set of monitoring solutions that you can choose. Obviously there are open source projects out there which you can combine one two three four, and you should be able to see, okay, this is the right monitoring solution for me. So there is no perfect solution which is out there. Depending on the needs, it changes. For example, uh, you want to scrape data from not only from Kubernetes but from other components as well. So Telegraph is one option. So I'm not going to explain each and every one of them. Why? Because it they all are huge projects and it will take a whole day to explain about them. So but there are a lot of videos that I have done already, which you can maybe check out, or we can link that later. But Telegraph, InfluxDB, and Grafana is one of the solution. You can have Telegraph, you can have InfluxDB, which is the time series database again, and you can have Grafana. So Grafana is a visualization tool. Grafana is almost everywhere because to visualize and see the dashboard, all the fancy dashboard that I was talking, they like come from the Grafana. And so Prometheus is also like there. So you have Prometheus, which is there. Then you need to have a highly available Prometheus. You need to have, I was telling you, there are multiple clusters and you need to have a single view, and you need downsampling of the data. Meaning, what does downsampling mean is, say for one day there are 100 containers emitting the metrics every minute. Actually it emits every second, but let's assume it is emitting every minute. But what we want is the highest value, the highest CPU consumption of this of the container by the end of the day, so we can downsample that data and store. Suppose you want that, so Prometheus alone won't be able to do that. Then you want a logging solution, so you want a tracing solution, Prometheus won't be able to do that. So you have to combine different stuff. So Prometheus and Thanos makes Prometheus highly available. It adds long-term storage. Prometheus doesn't have long-term storage. It will fill your box pretty well, and Thanos can be living across across different cluster, and you can connect different Prometheus running in different Kubernetes cluster to Thanos, so you can have a single view. That is also very important. Now you can have Jaeger for tracing, Loki for logging, Parka for profiling, Grafana for viewing. So those are there. You can also have solutions like Victoria Metrics and ClickHouse, Grafana. So again, depending on the use case, you need to obviously do some POCs and select the right um, monitoring solution. In today's demo, what we'll be doing is I will be deploying the complete Prometheus stack, just to give you a feel like what metrics are, how we can visualize them, create Grafana dashboards on the Civo Kubernetes cluster, what all components are there that emit metrics, how it gets converted. We'll get we'll see all that fancy stuff. So yeah, on the right hand side, you can see there is like a long term storage, managing at scale, highly available, structured logging. You need tracing, profiling, you need trends data. So trends data can only come when you have the data for 3 years. Then only we will be able to see the trends, which is very critical for the business use cases. Then latencies, dashboards. So with respect to that, you will be choosing your monitoring solution. I hope you got some idea of what all monitoring solutions are there, and what are some of the challenges, and how you can pick and choose some of them. Let's go to demo. Before going to demo, yeah, let's go to the demo. There are two slides which are related to the demo, so I can actually come back later to this particular demo. uh okay, now I'll share my terminal. Okay, not the terminal, obviously. So what we'll do is, I think you already have seen this particular stuff, which is Kubernetes clusters. So this is my Civo account, and I will be creating a cluster in front of you, Prometheus, and I will just give it everything. I'll create a large cluster, and I'll do nothing. I'll do a create cluster. So the cluster is building. Now, meanwhile, it is building. Let me tell you what I am going to do. What I am going to do is, where is, yeah. So what we'll be doing is I'll be installing full stack, which is from the basically the Prometheus, complete stack, which is called Cube Prometheus stack, and we'll see what all components. Obviously, it gets installed. I will just show you actually. Yeah, we can see that before the demo. So it's loading. Yeah. So this is the complete stack that we'll be installing. So it will be creating Prometheus and Alert Manager stateful sets. It will be creating few deployments like Cube State Metrics, Prometheus Operator, Grafana. It will be creating a daemon set, which is for the node exporters. Daemon set is something which runs on every node when created. It is that Kubernetes object. It will definitely create some config maps, because there are some Prometheus rules which are defined. There are a lot of rules like how to scrape which metrics Prometheus has to know. Those comes from these rules. Next is the secrets. So obviously there are a lot of secrets like the Grafana username, password, the certs for Prometheus, how they're communicating. So all those are stored as secrets. Then there are a bunch of CRDs, custom resource definitions. So since this is a Prometheus operator, so controller is there, and it can it can watch for custom objects with like you have seen like kind pod. So there can be a kind service monitor and kind Prometheus rules. We can define a YAML file with respect to that, and we can deploy that. So we are doing everything from scratch. I'm not doing anything which is not from scratch. So let's go back. Our cluster is ready. As you know, the power of Civo Kubernetes, it gets ready, and I am done explaining. So I'll click download. I download the kubeconfig file. It is called Civo Prometheus kubeconfig. And now I switch back to my terminal. So I need to share my terminal for that. Let me stop share. Now you will be seeing my face, and let me share the terminal window. Awesome. So kubectl get nodes. See if this works. Perfect. So you can see the cluster is up and running. Its age is 56 seconds, and I haven't done anything fancy with respect to that. And so there's a question, what is structured logging? So basically, getting the logs in the kind of format that is understood by some of the toolings. So that can be called as structured logging. And then you have, I'm just seeing my gist. Where is that? Okay. So what we'll do is we have our Kubernetes cluster, and we have exported our kube config file. That is how you do that. Now I do a helm repo add Kubernetes. It will give me error because it is already there. So I don't need that. I just performed that demo already. I will do a helm repo update on my repository. It's already, I mean, helm repo update will update all my helm charts, but it is also doing the Prometheus community one. This is what is important to us. Let me clear the screen. And now it is here's the deal. So Helm install the release name and Prometheus community, the chart which is actually there. Now it is doing bunch of stuff. It will be installing bunch of stuff, so it will take some time to install. In the meanwhile, what we are trying to do over here is we have taken a Kubernetes cluster, and we are trying to install the complete Kubernetes Prometheus stack. There are different components that will be installed, which I showed in the slide. You can install those components separately. You can install Prometheus separately. You can install your and create the rules separately. You can install the CRDs separately. You can install Grafana separately and create a service for it. You can install the node exporter daemon set separately and have that. But this is a single stack. Now this will help you eliminate all the all the burden of installing. It's a community maintained project. I can actually put the link. Let me just find the link. Kubernetes monitoring, Cube Prometheus stack. Just a second. Cube Prometheus stack. GitHub. I'm also searching, so it should be fairly simple. There's a Cube Prometheus stack. It keeps on getting updates, so it's fairly maintained repository. So I'm fairly confident in using that. So here it is. Just sent the link in the chat that you can see. So that is what we have done. So we have used Helm. If you can see in the repository as well. So there is a installation steps which are mentioned. How to install that. You just do a Helm repository add. You do a Helm install, give the release name and install, and it has some of the dependent charts again, which is like the Grafana, Cube State Metrics, and Prometheus node exporter. Now actually Cube State Metrics doesn't make any sense for our K3s clusters, because the cube state metrics actually monitors the what you call Kubernetes components. But since this is a K3s based clusters, and the master is managed by the managed by us, the control plane is managed by us, so the cube state metrics won't make much difference. But yes, the node exporter will definitely do a lot of stuff. So it is deployed. Now what we'll do is, instead of speaking, kubectl get all. We'll see what all things are what all things have been installed. So I told you, like, there are two stateful sets. They are the most important components, which is they are the most important components, which is the cube Prometheus stack Prometheus. So this particular stuff will be managed by the operator. So this is the operator. This is managing the stateful set, the config maps, and other stuffs. Now there are deployments, and deployments are for the Cube Prometheus stack operator. So obviously the operator is managing all this stuff. Cube state metrics, not very much important, but since it comes as part of stack, so it is there. And you have the Grafana. Now again, I told you there is a daemon set. Now daemon set is a node exporter. So basically, on each node, what is happening, the network traffic, the CPU, memory. I'll show you the graph, so then it'll be a lot clear. Like, so many things can be there that we can capture. So that is there. And these are the bunch of services that it has created. Some of them have the cluster IP none. Cluster IP none means it is a headless service. So headless service is actually used within for the stateful set. So that is why the Prometheus and the alert manager have that headless service. And you have the Grafana service, which definitely what we'll do is, let me do a kubectl edit svc Grafana, because we want to access that. We can do that as a node port. And then what we'll do is, let us kubectl get svc hyphen a. Yeah, that is fine. So we have a bunch of services. Now I want to show you kubectl get config map. So I told you there are bunch of configuration maps that have been created, like for the node for the stateful sets, for the scheduler. Obviously we don't need these, because etcd, because it's K3s based, right? But since it comes as part of stat, that is why it is there. Then you have for the certificates, then you have your Grafana, and then you have this one. Yeah, this one is the most important one, which is there, like kubectl get cm this hyphen o yaml. We can see what is there. So it will tell you what all things it is capturing, what all queries, what all data sources are there, what all scraping it is doing. Let us see how much big it is. Yeah, so you can see Prometheus JSON is applied over here. We can edit that, or we can choose the so it is, yeah, it is capturing the target. So that is where there are the targets that it is capturing, which is good. and also kubectl get secrets. Obviously we need the Grafana secret. So Grafana secret hyphen YAML. So we have the username and the password I told you. So let's do the password echo echo a64. So prom operator is the password. I am pretty sure that the username is admin because I just tested that earlier, but you can do that in a similar manner. I want to just show you. So there are a bunch of other passwords as well. The secrets created as part of the deployment as well. So now we have the stack deployed. We have the services, we have the deployments, we have the daemon set, we have the operator, we have the stateful sets managed by the operators. So all these components are there. Now let's go back to the UI. So the part of the what you say the terminal for now is over. So but we need the IP. Actually, we can take the IP later as well. But anyways, I'll take from here. And let me just switch back my screen. You can see my face. And which screen is there? Okay, I think this one. Yep. So I have given the IP because the Grafana is exposed to the node port, and then the Grafana port is given as it didn't change to node port. Let me do it again in the back end. Cubectl edit svc. Oh, wow. Node port. Okay, now it is done. So this is the port of Grafana 30118. Oops. I hope the Grafana is loading for you. So the Grafana is there. We have the username and password. Yep, we are logged in. Perfect. So now we are logged in. So I hope I have covered everything. Let me just check. We have done this. We have done this. We have the Grafana service. I showed you the config map and the secret. And awesome. Now what we'll do is we'll add a dashboard. That is where the dashboard is. We'll import one of the dashboard which is already there for the node exporter. Very fancy. It is too much fun. I'll show you. It is loaded. I'll select the data source which is Prometheus. We can actually add different data sources. We can use a single instance and we can have that. So you can see the fancy what you call perfect. So fancy dashboard is there. So there is a data source is there, node operator, a node exporter, and you have three node cluster. You can see over here, I have a three node cluster, 1, 2, 3 that I created, and the node exporter is something as a daemon set, emitting a lot of metrics from node, and Prometheus is able to scrape that. So that is the job of node exporter that it is doing, and this is how you can see that, and you can set the alerting on top of that. That is the power of the Prometheus and the metrics. You can see how many fancy graphs are there. You can see the, let's say, the memory info. So you can see all the memory information, and let's see what all things are there. We can actually see the storage disk information, the IOPS information. We can see the node exporter metrics itself, what is happening. We can see the net stat. We can see the network traffic. So you can see that, and we can see what is happening, which v0 and all that stuff is taking up, how much min, max, average, and the current. So I think that's pretty interesting. this graph is I really like it because it is built by the community, and one of the coolest graph out there for with respect to the node exporter. You can definitely bring build your own graph. So like, let me save this dashboard just like that. I can just create a new empty panel. I can then choose my data source, and I can query from here. I can create my fancy dashboards over here as well, so which should be fine. So this language will be promql. So you can see a promql query, like cpu is there, and query inspector. So you can see I have the query over here. So you can do these sorts of query, and save your own kind of widgets in the panels inside your dashboard, and build your dashboard like the one I showed you earlier. On the other hand, I want to show you that I installed. So I have another cluster, because I don't know how much time we have. So I have another cluster which was Thanos I built, and I did install one of the application from the marketplace, which is called Parka. So this is the application, and I installed this particular application. So Parka is basically the open source infrastructure wide continuous profiling. So it does the continuous profiling for the application, then the infrastructure. It helps obviously save, improve performance, money, and the incidents better. Obviously it's Prometheus native, so it can capture the metrics. For that, a lot of stuff is mentioned. So I already have installed Parka. I can show you that. What we'll do is, I'll share my entire screen. You'll just see some random stuff which is there on my screen. So, because else I have to share stuff again and again and again and again, and I'm not liking that. Cool. So this is my other cluster, and you can see the CRDs as well. So kubectl get nodes. I think this is a few hours old cluster. Let me just check. Yeah, this is a few hours old cluster, and I have a lot of stuff already installed. So like kubectl get pods -a. You can see I installed Parka agent, and all that stuff, the deployment with respect to the from the Civo marketplace. So it is there. Now what we'll do is, let me just port forward it. So it is running, and I'm just doing a query. So this is where so sorry, this is where I wanted to show you the continuous profiling stuff. So this is Parka, and this is the continuous profiling, and I have done it for the past hour. I have queried it. I'll just reload that. So basically what I'm doing is, I am comparing the CPU samples of one node to other node for the past 1 day, and I am comparing that. So you can see how they both are performing with respect to that's basically the CPU samples. And I can do a lot of other stuff. I can do it with respect to the containers, the namespace, or the node itself, and bunch of stuff. This is the continuous profiling, and you can go to querying Parka, which will give you a simple label selector query based language. It will tell you like how this works. There is a merge over time. We'll If we do like a merge over time, it will give me a sorry, I removed that query. So if we do a merge over time, it will give me this particular stuff. How to understand that, you can just go over and see, and you can again compare different cycles that I showed you. So I think it's pretty cool, and pretty interesting, and making use of the latest and the greatest in tech. And this is where the marketplace application of Parka lived. It was submitted yesterday. Another thing which is very fancy, and I want to show you that, is where we are. Okay, this terminal. Now you're building applications. Now you want your sorry, now you're building applications and you want to send data from your applications to in the Prometheus format, and you want Prometheus to scrape the metrics from your application and also build graphs on top of that. That is what we are here to do, right? So I have a file. I don't know which file is that. Okay, test Python. So I have already installed the Prometheus client. It is basically the pip install Prometheus client. I think that's pretty much it. And I have imported start HTTP server. This is just a simple one. And what I'm doing is I am doing so Prometheus metrics will be available at this particular thing, and this is the server handler. I have created that particular server from the HTTP server, and I'm calling this particular function, defining this particular function. The server handler is there, and you have the response and writing the metrics and all that stuff. So if I go to 8001, basically it should print hello world. If I go to 8000 slash metrics, it will show me the metrics in the Prometheus format, which actually Prometheus can scrape. So let's go back, and you can see I am on localhost 8000 metrics. It won't run at the moment, but Python test.py. So now it will run. So even if I reload, I know it's not something that won't load or something. So it is there. So metrics is there. And if I go to 8001, I believe, yeah, it prints hello world. So you can see, the metrics which is coming over there. So I think that's pretty neat. And which is coming. That's how you can actually use. You can go to Prometheus. Yeah, you can see, how you can use. Basically, there are exporters. You can write your own stuff, and then create in such a format that when you want to scrape the metrics, you need to use them here. So kubectl get pod. um I think this one should be there. Get pod. Why this pod is not there? Oh, this is service. Kubectl get pods. My bad. So Prometheus stack operator. Kubectl get pods. I mean, you can define those rules. I'll just see if I can find the YAML right now, and we can query some stuff. So you can see this gives the image, and what else? And it gives the config reloader stuff which is there. At even the Thanos default base image is there. Then you have the enable TLS which is there, and then you must have some of the stuff which is, just a second, in terms of volumes. So you have the volumes which is there, and you are taking the secrets from there. And I think the config reloader must be reading the kubectl get config maps, and we can actually write another rule. Yeah, so we can write a particular rule with respect to the Prometheus, and we can add whatever we have written, and wherever we have posted that to this particular stuff. So I think we had one more slide. Yeah, So again, that was the same slide I explained that earlier. So it creates a stateful set. Stateful set is actual Prometheus server managed by the operator. So basically, when you search Prometheus GitHub, you won't see the cube state metrics or the other fancy stuff. You will see Prometheus as a time series database. That's it. Because Prometheus is a time series database, it will tell you, the Prometheus is a CNCF project and it's a time series database. Have the PromQL as a query language, and this is how it works. And even how to run it will be in Docker, so you won't get any of the fancy stuff which I just showed you. That is there in the cube stack, the Prometheus full stack which is there. And then you have the deployment. So the Prometheus operator is created, operator creates the stateful set. Cube state metrics is there for Kubernetes components metrics, and Grafana is for the visualization. Those are the deployments. And then there is a daemon set which is there for node exporter. We have already seen the node exporter fancy dashboard as well. Just by adding the JSON, you can actually create your own okay, it's logged out. So you can create your own dashboard with the JSON as well. So I just took one of the imports which is there by provided by the Grafana. So I'll stop share here. That's pretty much it I had with respect to Kubernetes monitoring. I hope you learned something with respect to Kubernetes monitoring, observability, pillars of observability, and why Kubernetes monitoring is important, different solutions out there, and how to deploy the complete stack, and then the continuous profiling, and how this works. You can have your the application export metrics in the Prometheus format, and let Prometheus scrape that. You can what you can do, yeah, you can do continuous profiling as well. You can have data visualization using Grafana. And yep, I think that will give you enough information to do some hacking on Civo Kubernetes and build something cool. So thank you all for tuning in. If you want to learn about Jenkins, there's a stream tonight 9:30 p.m. on my channel with Oleg, one of the core maintainers, and the CD Foundation TOC. So be sure to tune in if you want to learn awesome stuff. So thank you all for tuning in, and good to see you all. Have a nice day. Bye.